Hey YouTube, we're gonna go through rules for logarithm, and this is a revision. Here is the set of questions and GCSE problems. You can pause the video and try to go through. So that's the first set. So this is the second set. And in the end, exercise 3 is challenging task, sort of like GCSE extended, but you may try. Okay, it's also based on the rules for logarithm. And we're gonna get started. All right, so let's try to attempt the first one. Without using calculator, simplify the following logarithmic expressions. And we have the first one. So I'm zooming in, and we're gonna write that as. All right, so guys, just remember log with the base a of some y is equal to x, you always can translate into exponent form. That's actually what you're supposed to do. So without using calculator, simplify the following logarithmic expression. I'll be using that, and that's why for each one I just simply try to show what it equals to. Log 216 is some power x that you need to rise to in order to get 16. So obviously it's 4, right? So we'll get 4 here. And in the same manner, now let's do it mentally. We need to raise 2 to some power in order to get 4. So obviously the power is 2. So it's 4 over 2, or just simply 2. Okay? That's the solution for the first one. So keep in mind that you are able to do that. Okay, so here, oh, it's double actually. So the answer is going to be the same. So 4 over 2, my bad. All right, so log 5 25 over log 5 1 over 5. Okay, let's try to do that. 5 squared is how you get 25. So one more time, log 525 is some power x, so that 5 to the power of x, you need to get 25. So obviously x equals 2. So we'll get 2 over, and here log, let's do that, log 5 1 over 5. So again, some power x, so that 5 to the power of x should be equal to 1 over 5. But 1 over 5, we can write as 5 to the negative 1. So obviously x is just negative 1. So we'll get over negative 1. So that's why the final answer is negative 2. All right, so that how it works. I just simply erase that, or maybe just transfer. Let's try to transfer somewhere here. Okay. Okay, let it be cut off. Okay, so next one. Without using calculator, simplify that. And now we go back to rules for logarithm. So first rule, 1. So I can represent 1 as log 4 with the base 4 and of the 4. So we just simply do that, because 4 to the power x equals 4 means 4 to the power 1 equals 4, so that's simply 1. Okay, I just rearrange that 1 is log 4. Why? Because everywhere we have log with the base 4, and that will be helpful. Okay, so try to retain the same basis as you have everywhere for logs in the expression. Okay, so that's 2. I just go up, right, and lift as the powers. So I'll get, using the property about the powers, I'll get log with the base 4 and 3 squared. Okay, that's how it works. So next one. Obviously, I keep minus, no problem, and I raise this 3 as the power of 5 now. Okay, I'll get that one. Okay, so that we arrived to all logs with the same basis, and now I'm going to use the property about addition and subtraction for logs with the same basis. So what I'm going to do, here I have multiplication, so simply leave log with the base 4, and now I'm going to multiply 4 by 3 squared, which is 9, so 4 by 9 is 36, but I'll write like in more details. Okay, and because I subtract 5, simply log 4 5 cubed. 5 cubed is 5 squared, 25, and one more time times 5, I'll get 125. So simply I will divide by 125 in the end. And that's my number. So log with the base 4 of some number, okay? And that's without using calculator, just simplify. So I'm not supposed to calculate anything. So I just simply use log 4. And I leave 4 times 9 is 36 over 125. Obviously, you can calculate if you want to do that. So like in order to get some decimals, I don't know, fractional number, surds. So in this case, obviously some decimal. You just need to use calculator and calculate. So I just, for some reason, I'll give you the answer if you want to calculate that using the base log 4, and I'll do quickly. Just wait me for a while. Actually, in this task, you are not supposed to do that, but actually, yes. On my calculator, sorry, I don't have the log with like any base, and that's why I'm not able to do. So, okay, yeah, I have only like log with a base of 10. So, but just using calculator, you need to press the button as the phone. So just simply need to press on your scientific calculators. So log x with the number, that's sort of the button, and that what you need to calculate. So that's by calculator, by calculating. Okay, so that's not the purpose of this problem. Okay, so we'll go next and we are going to simplify that one. All right, so we have m and n inside log, but I noticed that the base is 3, so I just lift up the power 2 and 7 correspondingly, and I'll get the following. So log 3 m squared and plus log 3 n to the power 7. So that's the property I used. Okay, and here what I'm gonna do, because we have addition of logs, no coefficient, so no coefficient before logs, so it's simply the same in 1, and we just need to multiply m squared by n to the power 7, and then take the log with the base 3. Okay, that's how we simplify. So make sure you did in the same manner. Okay, and we'll move next. So okay, exercise 2. And 2, you need to write y in terms of u and v for the following equation. So basically you need to write y in terms. So what does it mean? It means you need to set up y equals to something. And that's going to be some expression from u and v, okay? Some sort of expression from u and v. Okay, let's try to do that. Okay, I have log 7y, and that's why, first of all, it's better to set up like both logs on each side so that I can freely go to exponential form. So instead of 1, I simply can figure out that it's log with the base 7 of 7, right? Because 7 raised to the power 1 is always 7, so that means the result of this logarithm is going to be 1, so I'll use that, log 7. Then I raise this 2, lift up according to the properties, and I'll get log 7 or v squared, okay? And then I just rewrite as the following. I have both logs with the base 7 on both parts, and here I apply the property for addition because, for addition for logs, but for multiplication for numbers inside the logs. So simply leave log 7 and I multiply 7 by v squared. I'll get 7v squared. Okay, and from where I can easily figure out y, because if log with the base 7 are the same, right? So what I can say that all internal expressions like y and 7v squared will be equal to each other. So y is going to be 7v squared, and that's going to be the final answer. So you can also try to raise 7 in the power log 7v squared, and you'll find out that log 7 to the power log 7 will be just cancelled, and you'll leave with 7v squared. Okay, so that's the final answer for the first one. So we got the first one. Let's move to the next one. So I'll start doing here. So log with the base 6y equals, so how to get 2 using the log with the base 6. So obviously you need to 6 rise to the power, or just simply, you can write again the property for like p log a of some, like, let's say number b is the same as log a and b to the power p. So that what actually I apply to. Okay, this sort of shortcut, so you can use that. Then I subtract 1/3, so I raise back to the power, so it's going to be u to the power 1/3. Okay, now what I'm going to do, I just simply use to come to 1 log on the right side, log with the base 6, and because I'm subtracting, I just simply need to divide 36, it's 6 squared, and over u to the power 1/3. Okay, so here, actually, you again came to the case when you have the same logs with the same basis, and y will be equal to 36 over u 1/3. So the final answer here is going to be 36 over u to the power 1/3, or you can simply rewrite, so that's actually the answer already. I just highlight with the yellow. Or you can also rewrite, or another form, if you use the surd notation, so you'll get 36 over, and that's cubic root out of u. Now here I used the property for surds and the property for indexes or index. Okay, so make sure you remember that. All right, so let's go to the next one. Log 2y equals u plus v. So here I just can't use log by definition. I just simply take 2 raised to the power u plus v, and that's how I can get y immediately. So we'll get 2 to the power u plus v. Okay, that's immediately the answer. Okay, so here I'll get log 5y equals negative log 5. So I'll take negative 1, because here actually we have negative 1. So I can rewrite like this. Log 5y equals negative 1 times log 5u. In this case, I simply can lift up my coefficient as the power for u. So in this case, I simply can state that log 5y equals to, I'll get log 5 u to the power negative 1, from where I can equate y and u to the power negative 1. So I'll finally get the following. So y is u to the negative 1, or I can also write as y equals 1 over u. Okay, so that's how it works. That's the final answer to this problem. Okay, so and the last one, so everywhere I have log 2, so I just leave log 2 y. So 1 over 2 I just lift up as the power, and I immediately can write as square root of v, right? So that's why I put square root of v, and negative 2, so I'll leave negative, and power of 2 I lift up here. So I'll get log 2 u squared. Okay, and because we have subtraction, I simply can do the following. Log 2 y equals to log 2, and because we have the difference, I'll apply the property for difference of logs, and that means I will have division square root of v over u squared. So from where I again equate internal numbers because of the same log with the same basis. Okay, so y is simply square root of v over u squared. So I used the surd notation, and that's the answer for the last log here. Okay, so make sure at least you did that. So that's the final answer. So one more time, zoom in and just make sure you can compare your writings, your workings with what I've got here. Okay, so we've done up to the second one, so the second block, and here we go to the challenge. All right, so in the challenge, what we're given that this logarithmic expression equals 1. So we have some like variables c or parameters c and k inside, and we need to express c plus 1 squared in terms of k. Okay, so right now what do you need to do? Obviously you need to simplify and came to expression something like that. Log 2, some expression that we have c and k, and that will be equal to 1, the right hand side. So first of all, we need to simplify up to that. So we need to get that. So try to get this form first of all. Okay, so we already know how to do that. We'll take 3 and we lift up as the power. So we'll get log 2 c plus 2, the whole expression's to power of 3, okay, and then we subtract log 2, and here is another expression, c cubed over 2 minus plus k, so we'll have still 1, okay. And now what we're gonna do, we just need to use the property for subtraction of logs, and that hence we can get what we're designed to do. So we need to get 1 log. So c plus 2 cube over, and here we'll get c cubed over 2 plus k. Okay, that's equal to 1. All right, so we've got that. And finally, what we need to do, we need to express c plus 1 squared. Okay, c plus 1 squared in terms of k. In this case, what we're going to do, we just need to take 2 and raise to the power 1. And hence we'll get c plus 2 cube over c cube over 2 plus k. We need to raise 2 to the power 1. We'll get 2 to the power 1. Alright, so now what we're going to do, we just simply need to use the property for, because that's sort of fractional one, 2 to the power 1 is 2, and then we simply need to make a crisscross. So c cubed over 2 plus k goes up. That's a bit more complicated, but anyway, we can do that. C cubed over 2 plus k. Alright, so what we're going to do, we need to express c plus 1 squared in terms of k. Okay, if it were like k in terms of c, that's already the answer because k already stays alone on the right hand side, and we simply can move it c cubed over 2 to the left hand side. However, here we have like another question, we need to express c plus 1 squared in terms of k. So hence what we're gonna do, we need to obviously try to simplify c plus 2 cubed. It means expand. So we can try to expand c plus 2 cubed. Okay, so what we're gonna do, simply we can express as c plus 2, so one more time, yeah, c plus 2 squared and times c plus 2, that's what we get, and that will be equal to c cubed over 2 plus k. Okay, so let's try to simplify that. We'll get c squared plus 2 times 2, we'll get 4c. We use the formula for expansion, right? Just remember. a plus b squared, which is a squared plus 2ab and plus b squared. So we use the formula here, and hence we just simply expanding in this way, and that's c plus 2 and minus c cubed over 2 equals k. Okay, so what we can do now, we can try to expand the brackets. So simply we need to take each term from that brackets and multiply by each term here. That's how it works. Or of course we can immediately apply the formula a plus b cubed equals to something, but I just want to show if you forget, because this formula is not like widespread, and that's why it's better to expand it with no errors, because this way is less error prone. Okay, now we'll get c cubed, then plus 2c squared, then we'll get 4c squared and 8c, then add 4c, then actually add 8, and minus c cubed over 2 equals k. Okay, so that's what we've got from there. All right, yeah, that's what we've got. Okay, so c cubed, now let's simplify and get some similar terms. And we'll get c cubed over 2. Then, what about c squared term? It's here. Then we also can add c terms. So we'll get add 6. So we get 6c squared. Then 12c plus 8. And we can transfer even k to the left hand side. Okay, so what we got, I multiply by 2 in order to get standard cubic equation. That's cubic equation. All right, so cubic equation. You'll get a phone c cubed plus, will times 2, a 12c squared plus 24c plus 2 times a minus k, because I consider 2 times a minus k as which term? As simply, I consider as the single term, as free coefficient. All right, so we've got that, and now we need to find the answer of this equation. So finally, we need to find the roots. Okay, so that's a bit more complicated. I guess this should be done in terms of, like using calculator, because it's pretty hard to do that. And you see that we have c cubed, 12c squared, 24c, and on the right hand side we have some expression linked to k. So I guess here express c plus 1 squared in terms of k. It's a bit more complicated because you know what? Because we have like some parameters, right? And we are supposed to express c plus 1 squared, so that's why actually, can we figure out what c plus 1 squared is? I'm not really sure, because it's less likely that we can find this term here. So if you're able to express c in terms of k, we can get an expression where c connected with k. And then you simply need to add 1 to that expression and square it up. Okay, so let's try to go online. I'll just try to search quick about how to solve this cubic equation, because if it were one parameter here, and free coefficient becomes a number, we can freely do that using some first guess. Then we express cubic expression as some linear factor multiplied by quadratic one. But actually it seems to me that either in this task there is a misprint, so probably you need to express something like c plus 1 cube probably, or you need to have another expression for that one. I'm not sure that they have a right structure for that. Okay, so at least we've got the final like cubic expression and cubic equation where we can connect c and k using just normal roots, right, for cubic equation. So simply you need to, solve in general way and try to connect c and k. But it seems to me is misprint here, so I just give you like final steps. I'll just check this exercise and problem later on because right now I see that definitely misprint here. Okay, but general way of how to solve that is I lay it out here. Okay, that's the final what you need to at least have. Okay, so hope you enjoyed. That was rules for logarithm. So be focused on the first and the second problems because they are like the primary goal for that. And so what about challenge? I guess there is sort of misprint. Excuse me for that. I just captured that from one source and decided to try to undertake an online way just right now. I didn't see it before. I didn't solve that. So I always actually, when I try and to show you the way how to solve, like, and going through the past GCSE problems and GCSE questions, I never used to solve it before, so I do it on the run. Okay, so guys, hope you enjoy. Just one more time, try to check your answers, like try to reconcile what you have. Is it like the same way, or probably you've done in a different way? However, this way, what I show you is actually based on the main properties for logarithm and logarithmic formulas. So hope you like that. Don't forget to subscribe. This is the rushing hours before your GCSE examinations for mocks. So hopefully I think it will be useful for you guys. Thank you and peace out.